The last couple of lessons we've been talking about sine, cosine, and tangent. We've talked about their ratios, we've talked about how to use them to find missing sides, and today we're going to add how to also find an angle measure using sine, cosine, and tangent. So here we're given a right triangle and two sides. In each of these problems you're going to be given a right angle and then two more pieces of information. It's either going to be two sides, like it is here, or they're going to give you one side and one angle. And with that information, you can find all the other missing parts of the triangle. Now, you've learned before that you can use Pythagorean theorem if you have two sides of a triangle and need to find the third side. So you could go ahead and solve this one. You can do 5 squared plus 12 squared equals c squared. And when you solve that, you get c equals 13. That's something you learned last year. So we can use that. Then if we want to find angle A, let's say angle A is our x value that we're looking for. We can use sine, cosine, and tangent for that also. For this problem, we have all three sides, so we can choose which of the trig functions we want because we have the opposite, the adjacent, and the hypotenuse. So any of them would be fine. I'm going to use cosine to find angle x. So I'm going to say the cosine of x, and I'm going to find that ratio. Pardon me. We know cosine is adjacent over hypotenuse. So for angle x, 12 is my adjacent, and 13 is my hypotenuse. Now, in order to find x, we need to use the inverse of the cosine function. So when I say inverse of the cosine function, I want you to think about the operations that we already know, like addition and subtraction undo each other, addition and subtraction. So they are inverse operations. Multiplication and division are inverse operations. Squaring something and taking the square root, those are inverse operations. So sine, cosine, and tangent also have inverse operations. And the way we write the inverse of cosine, so cosine is our function, the inverse looks just like cosine, and then it has a -1. If you look at your calculator, you can see that above the cosine button, it says cosine -1. That's the indication that that's the inverse of cosine. So to find x, we're going to use the inverse of cosine of our ratio, 12/13. So in the calculator, we're going to plug in, let's bring our calculator back over. We're going to say second cosine. We're going to go ahead and do 12 divided by 13. I would just do the division right here on the calculator. I wouldn't do it separately. And hit enter. 22.6 is the angle measure. Now for angles, we usually round to the nearest degree. So since it's 0.6, that'll round us up to 23 degrees. So x is about 23 degrees. So that's our angle A. Let's see, angle A is 23 degrees. Angle C, well, since we know that they have to add, well, first of all, we know that the acute angles of a right triangle are complementary, so that we know angle C and angle A have to add up to 90 degrees, so angle C is 67 degrees. And then our missing side we had was AC, and it had a length of 13. Okay, let's look at this in a real example. Here we have a school that wants to build a raked stage. So a raked stage is lower in the front and higher in the back, but they don't want this angle to be a great angle for safety. So it says the stage will be 30 feet long from front to back with a total rise of 2 feet. So your rise of 2 feet is back here. The actual stage itself is 30 feet long down here. And they want the rake, that's the angle of elevation, to be 5 degrees or less for safety. So is the raked stage within our desired range? So we want to find angle x and figure out, is it less than 5 degrees? So for this triangle, we're given the 2 feet, that's the opposite side, and 30 feet, that's the hypotenuse. So for this example, we're going to use sine. So the sine of our angle x is equal to opposite over hypotenuse. And remember, to find an angle, we use the inverse of the function, so sine, inverse of sine of 2/30. You can simplify that if you want, since the calculator is going to do the computation anyway. It doesn't really matter. You can decide. So we're going to do the inverse of sine of 2 divided by 30. And it's 3.8, which is definitely less. I am going to go ahead and round up to the nearest degree, since that's generally what we do with angles. So 4 degrees. And then you would make a statement. Since the angle is 4 degrees, which is less than 5, it's within the desired range for safety. Okay, in this example, we're talking about the Uniform Federal Accessibility Standards that set how steep a wheelchair ramp can be. You can see that pushing a wheelchair would be more difficult, or rolling your own wheelchair would be much more difficult the steeper the incline is. And for safety, if the person were to roll backwards, you don't want the incline to be super steep. So they don't want the angle to be any less than, any more than 4.76. This is your ramp here. Now, they want the ramp to have a vertical rise of 8 inches. That's this amount right here. And it says you want to minimize the horizontal distance taken up by the ramp. So draw the diagram showing the approximate distance of the ramp. So what I want you to keep in mind is, in order to minimize the horizontal distance, we want to use exactly 4.6. It could be less than 4.6, but if it's less than 4.6, if that angle is smaller, then in order to still get that same rise of 8, if this is smaller, this horizontal distance needs to be a lot longer. And so in order to keep that as short as possible, I'm going to go ahead and delete these pictures. We want to use exactly the 4.76. So let's draw a little bit better image here. 4.76 is a tiny, tiny angle. If you look at a protractor, it's going to be very small, much smaller than what I've drawn here, but just to give us an idea, this is 8. And we want to find the approximate dimensions of our ramp. So we want to find the length of the ramp itself, and we want to find this horizontal distance here. And we've got a right angle here, which gives us the right triangle. So let's find x first. Well, for this angle, 8 is our opposite side and x is our hypotenuse. So we're going to use the sine of 44.76 degrees is equal to the opposite, which is 8, over the hypotenuse, x. This is like one of the ones we did the other day. Since it's divided by x, we can just flip-flop the sign and the x. So x is equal to 8 divided by the sine of 4.76. We'll grab our calculator. And we'll do 8 divided by the sine of 4.76, which is about 96.4 inches. So the length of our ramp is 96.4 inches. And then we want to find the length of y. You can either use the Pythagorean theorem now that you have 2 sides, or you could use the tangent of 4.76 since you have the opposite 8 and you're looking for the adjacent y. So to find y, we're going to do 8 divided by the tangent of 4.76. So 8 divided by tangent of 4.76. And we get 96.1. So the horizontal distance of the ramp is 96.1 inches. You'll notice that there's not a lot of difference here. That's because the angle is so tiny that the ramp itself is just a little bit longer than the actual horizontal distance that the ramp is traveling. Okay. Those are the examples for today. What I want you to remember is you only use the inverse functions, inverse of sine, inverse of cosine, and inverse of tangent. These are only used when you're trying to find angles. Used to find angle measures. If you already know the angle measure, then you're using regular sine, cosine, and tangent like we did on this last example. Okay, your homework is on big ideas. This is section 9.6 in your textbook, so that will be where the assignment is.